Here we are, Pre-Algebra Chapter 4, Graphing and Writing Linear Equations. We're going to be using the flipped classroom model again, so when assigned, please watch the videos. You can see down here that we've got a QR code on this, so if you have a QR code, you can simply scan that with your phone and it will take you directly to where the videos are, or you can go to the trumanmath8.weebly.com and find them there again. If you didn't already, go ahead and write your name and your hour on your paper, and then let's get into this. So, if you need to pause the video because I'm going too quickly, then you can do what you need to do to get down proper notes. So, a linear equation is an equation whose graph is a line. Root word of linear is line. The points on the line are solutions of the equation. You can use a graph to show the solutions of a linear equation, and the graphs below or represent the equation y equals x plus 1. So you can see we've got a table here. We are going to be showing you how to create tables, and from that table you plot these points, -1, 0, 0, 1, and 2, 3, and then you connect that to make the graph for this line. So here are our steps. You make a table, you plot the ordered pair, you draw a line through the points. Make sure your line goes all the way across your graph. Use a ruler would be great. Make sure you have arrows on the end. Your line does not stop just because you run out of graph space. So if we look at this one, we're going to leave the steps up here so that we can see those. So if we look at that one, if we look at that one, we're going to make a table of values. You can choose, so we can choose x values. Okay, but they would always suggest, I would always suggest that you use some negative x values. So let's use -1, let's use 0, and let's use 1. So negative x values, 0 and 1. 0 is super easy to plug in. It's a great one to use, and 1. So these are the typical values that we are going to choose for x. And we'll talk about when you may need to use some different ones later. In this section, it's kind of like your workspace. You're trying to find y. What is y? Y is equal to this. So in this space, we're going to do -2 times x. So times, I'm going to use parentheses for that, times -1 plus 1. And then we do this work. Use a calculator if you need to. -2 times -1 is 2, and 2 plus 1 is 3. So this point is -1, 3. Do the same thing here. Do -2 times 0. I'm using a dot this time for multiplication. It doesn't matter which one you use, although it may be confusing up here if you don't. I'm going to make this parentheses as well, and you can do the same. So -2 times 0, anything times 0 is 0, plus 1. So this point is 0, 1. And then this point, -2 times 1. Where am I getting the 1? It's from here. This is x from the equation. So -2 times 1 would be -2 plus 1 is going to give me -1. So this point is 1, -1. To graph these points, you will always start from the origin and then go left and right. I'm sorry, I'm trying to arrow down on my screen. You will go left and right. So from the origin, you go left 1 and then up 3. Okay, I always say you have to walk in or out of the elevator before you go up or down. You go to 0 and then up 1. You go to +1 and then down to -1. Connect those the best that you can. It's hard for me on the screen. Use a straight edge would be great. Connect those. If they are not all three in a line, there's a problem because these are linear equations and they should make a line. So we chose the x values. We're going to use -1, 0, and 1 typically. We plug them into the equation to get the y that goes along with the plugged in x. We plotted those points. We connected and made arrows on the end. Here is a key idea for us, and we'll get more into this later, but graphing horizontal. So this green line is a horizontal line, and then this green line would be a vertical line. We will, like I said, talk more about those later, but remember horizontal and vertical. So go ahead and flip to the next page. So graph y equals -3. Well, we didn't give ourselves a table here, so let's make a quick table just to talk about this. These are special types of lines. So when we give ourselves a table, all our equation tells us is that y is -3. What's y? -3. What's y? -3. What's y? -3. It does not matter what x is. So let's go over on our graph. Let's say x is 2. What is y? -3. What if x is 5? What is y? Again, -3. What if x is -3? What's y? -3. So you can see that these points are going to make a horizontal line right there. So anytime you've got y equals, that's going to make a horizontal line. Y is equal to -3 here and here and here and here and here and here, etc. Okay? This one, you can imagine if y equals something is going to be horizontal, x equals something is going to be the vertical one. Let's make a quick table in case you forget. These seem like the easiest graphs to make, but they're often the one that people mess up on. So, what is x? X is 2. What's x? X is 2. What's x? X is 2. So again, it does not matter what y is. We just have to go over to where x is 2. Maybe y is 0. Maybe y is 3. Maybe y is -5. It does not matter as long as x is always 2. Remember, this is the x-axis. So go to where x is 2, and all of the points that make up where x equals 2 is going to be your vertical line. Okay, so at this point, you should pause the video, and you're going to do the on your own problems. So what values are we going to use here? We're going to use -1, 0, and 1. You're going to plug those in for x up here, find the ordered pair, and graph it. However, down on number 2, because there is a fraction, you're going to be multiplying your x by a fraction. Instead of using the typical -1, 0, and 1, we are going to choose x values, write this on your paper, that are multiples of the denominator. So what are multiples of the denominator? The denominator in this case is 2. So we're going to use, instead of -1, let's use -2. That's a multiple of 2. Let's use 0, and let's use +2. If this were a 1/3, I would use -3, 0, and 3. If this were a 1/5, I would use -5, 0, and 5. Okay, that's going to help you get whole numbers for your y values when you plug that in. So I'm going to do a little bit of this one with you. We're going to do -2 times 2 plus 2. So half, we're doing negatives here. Negative times negative is positive. Half of 2 is 1. It's going to be +1, and +1 plus 2 will be 3. So even though we had a fraction, you're like, oh no, fractions, we wound up with whole numbers here that we can plot. Okay, carrying on to the next page, you are also going to graph number 3. Okay, and this is one of those special types, so you may not need that section there. Number 4 is also one of those special types. Refer back to what we already did. So again, you may not need this section here. And then after you've done those, come back and we will do example 3 together. So go ahead and pause to the on your own problems and then come back to here. All right, here's a real life situation. It says we've got a tropical storm, and here's its equation, where x is the number of hours after the storm enters the Gulf of Mexico. So if x is the number of hours after the storm enters, we will not use negatives. So we want to know about the storm after it's entering the Gulf of Mexico. So we will use, how about we use 0, and I'm going to jump a little bit just here to see what happens. So instead of using like 0, 1, and 2, let's use 0, 2, 4, and let's even add on another. Let's use 6. So in here, remember, you're doing the 2 times the x plus the 66 part. So we're going to do 2 times 0 plus 66 and do that math. 2 times 2 plus 66 and do that math. 2 times 4 plus 66 and do that. And 2 times 6 plus 66 and do that. So again, use your calculator if you need to. That's going to be 66. 0 times anything is 0. 2 times 2 is going to be 4. Plus 66 is going to be 70. 2 times 4 is 8. Plus 66 is 74. 2 times 6 is 12. Plus 66 is going to be 78. So the points that we are going to plot are 0, 66, 2, 70, 4, 74, and 6, 78. Okay, now you can see we've got quite a big graph over here. So the first things we're going to want to do is kind of figure out what our scale needs to be on this. So if I scroll down and over here, when you're given this much space, you want to kind of try to use it up. So you can see on our x's that we're starting with 0, so that's going to be here. And then let's space it out a little bit. Let's even go by halves down here. So let's call this one 1, skip 1, and then 2, and 3, and 4, and 5, and 6, etc. Okay, we only need to go to about here. And how do I know that? Because of the plots that I'm going to point. I'm only going over to 6. So I'll leave myself a little room to extend. Why not go ahead and put 9 and 10 on here because they fit nicely. So of course this is our 0. We'll need to put some labels on here. The X is going to be read back up at the top here, hours after Gulf of Mexico. So that's our hours. And we'll just put in Gulf in parentheses. And then going up this side, again, you want to try to use up most of your space. However, our first point is at 0, 66. So let's do a little break in our graph. Okay, so you just put a little squiggle there indicating that we're skipping some. And then let's start with 60 here. And then how about we just go by ones because we only need to go up to about 78. We've got lots of room. So that next one would be 61. So here's 62, 64. I'm going to pause and go ahead and fill this in, and I want you to do the same thing. So you pause right now and fill the rest of that scale. Okay, so hopefully you filled in the rest of these. Now we can start plotting points. So we're going to go to 0, 66 and plot a point. We're going to go up here to 2 and then to 70 and plot a point. We're going to go to 4, 74 and 6 and then up to, follow it carefully, up to 78. Okay, and then ideally use a ruler to make this line, and I'm going to do that while I'm paused here. So I have trouble on my screen making a nice straight line, but you should have a nice straight ray, technically. It's going to go on and on, put an arrow on this end, because it's going to go on and on forever in that direction, but we're not going to go backwards into negative hours into the Gulf. So there is your graph. Now we haven't answered our question. If we go back up to the question B, we graph the equation. When does the storm become a hurricane? Right here it said when the wind speeds are at least 74. So if we use our graph, sorry about that, when the wind speeds are 74, or we could use our table right here, but at 74 we are at what point? We are at 4 hours in 4 hours and 74. So 4 hours after the hurricane enters the Gulf is when it, or after the tropical storm enters the Gulf, is when it will become a hurricane. So that is it for today.